Hello friends, welcome back to the channel Learn with Art. Now in this video we are going to implement stack using linked list in C programming. So first I have included stdio.header file. Okay, so in this case stack is implemented as singly linked list, means the node structure for this is same as the node structure present in the singly linked list, means it contains two parts. One is data part and second one is pointer field. This data part we are going to consider here integer type. Okay, and so for that purpose we have taken here the structure, that is struct node will store integer data, that's why data part considered as integer type, and then the pointer field that store the address of next node in the linked list, so struct node star next. So this is the structure required to implement stack using linked list. It is same as the node structure in the singly linked list, and this will work same as the singly linked list. If you want to see how the singly linked list is implemented, then link for video on singly linked list is in description box. So now first we will make some assignments. So first I want to make top is equal to null. So here in case of singly linked list we have head node, likewise here the top will act as a head node. Okay, so first I will make top is equal to null because we don't have any element or any node present in the linked list, that's why I have assigned top to null. Okay, now here we will discuss first what will be the main function required. So in main function I have just called the push function, pop function and show function. Okay, so first we will push 11, then 22 and then 33. After that we will have one pop operation, then show operation to show current content of the stack. Okay, and then we'll return 0 as we have return type of main as integer. Okay, so if you want to add more number of elements or more number of nodes in the stack, then you can add or you can call the push operation as well as pop operation accordingly. Okay, so this was related to the some of the initializations and main function required for the stack using linked list. Okay, now we will have a look at the push operation. So we'll start with the push operation. So whenever main function calls the push 11 function, so our execution counter will go to void push operation, and now item will get value 11 from this first call. Okay, so now I have value of item is equal to 11. Now we will first allocate memory to the node. So first we will create a single node, then we will put value in that node. Okay, so first we will allocate memory, that is struct node star temp. We will create one temporary node is equal to struct node star, and malloc will allocate memory to temporary node. Okay, of size struct node. Okay, so now we have created a single node like this. We don't have any value added in this node. This is just single node we have created. Now we have to put values in this node. Okay, so for that purpose we have to check some of the conditions. If top is equal to null, means like in case of singly linked list we are checking for the head is equal to null. Okay, so here also we have to check whether the top is present or not, means if top is present then we have to add one extra node in the linked list, but if top is not present means we don't have any element right now present in the stack. Okay, so this is the condition, that is if top is equal to null means we don't have any element present in this stack. Okay, so we have to create first element and that will get assigned as a top. Okay, so if top is equal to null, as we have already assigned top to null in the initial global initializations. Okay, so this condition is satisfying, so it will move inside this if condition. So temp tends to data is equal to item. So we have created this temporary node, and now we have to put the values in this temporary node. Okay, so first we want to push element 11 in this node. That's why we will copy the value of item from item to temp tends to data field. Okay, so that's why first statement will be temp tends to data is equal to item. So this will copy the value of item into temp tends to data. Okay, now we will mark the next field of temporary node as null, because we have only single element to add in the single linked list. So no need to add address of next node in this linked list, because we don't have any extra node present in the linked list. So first we will assign null to temporary tends to next. Okay, now so 11 null. Okay, so this we have created a single node in the linked list. Now we have to assign this node as top, because we have currently single node in the stack, and this will work as top node. Okay, so I have assigned top is equal to temp, so top will be assigned as temporary node. Okay, so now this is my current top of the stack, and we have only one element present in the stack. Okay, so if condition is satisfied, so it won't go to else part. Now it will print %d pushed onto stack. Instead of this %d, we have to print temp tends to data. Okay, so here it will print 11 pushed onto stack. Okay, now this function push function is completed. Now our execution counter will come back to the main function, and the next statement to execute is again the push 22. So again it will call push 22 function. Okay, so our execution counter will go to push function. Now the value of item is 22. Okay, so it will again create one temporary node. Okay, so suppose this is our new temporary node. Memory will get assigned with the help of malloc. Now it will again check for the top is equal to null. So now if top is equal to null, but now we have top value of top as this node, so this condition does not satisfy, so it will go to the else part. So in else part we have to check whether we have to assign values to this newly created node. Okay, so I'll copy the value of item in the temporary tends to data field. So now the value of item is 22. Okay, so this will be copied in temp tends to data. Okay, so this is now new temporary node. Okay, so 22 will get copied in the temp tends to data field. Now we'll update the pointer field. So temp tends to next. So this is our temp node, and its next will store the address of top node. Okay, so now our current top is this node. Okay, so this will store, so newly created node will store the address of older node. Okay, so that's why temp tends to next is equal to top, means value of top will get assigned with temp tends to next. Okay, so this will point to top node. Okay, but now we will update the top as temp, because now our new top will be the newly added node. Okay, so temp will get assigned to top. Okay, so now this is our recent top. Okay, so temp will get assigned with top. Okay, so now else part is completed, and it will print %d pushed onto stack. So instead of this %d, 22, because temp tends to data is 22, so 22 pushed onto stack will get printed on the screen. And here the function call for push operation is completed for element 22. It will return back to the main, and the next statement to execute in main is again push 33. So it will call again the push operation with the value of item is 33. So first statement, it will allocate memory to the temp node. So one more temporary node will get created, okay, with the help of malloc. First condition will not be satisfied because now our current top is 22 node, so it is not null, so it will go in the else part. In else part, item value of item will get copied in temporary temp tends to data. So now 33 will get copied in temp tends to data. Again, we have to update the pointer field of this temporary node to the top. Okay, so this will copy top to the temp tends to next. Okay, so now this assignment will be done with the help of this statement, and now we have to update the top, that is we have to update top as newly created temp node. So temp will get copied in the top. Okay, so we have updated top as newly created node. Okay, here else part completed and 33 pushed onto stack will get printed on the screen, and here push function call is completed and it will return back to the main function. Okay, after that the push operation will be called. We'll explain the implementation of push operation in next video. Link is provided in the description box. If you have any queries related to push operation of stack using linked list, then please comment, and if you like my videos, then never forget to share and subscribe to my channel. Thank you very much.